sir, 1 minute, sir. Let me introduce. Sir, let me introduce you. Good evening to all participants. It's my pleasure to introduce Dr. Subramanyam Garu, Dr. G. Subramanyam, BE Accredited Energy Auditor, Directors, AICTE-ATAL and Carbon Advisory Service Private Limited. Dr. Rajan, am I audible?
Yes, sir.
Okay, thank you. Bureau of Energy Efficiency, BE Accredited Energy Auditor, with panel expert with UNF, CCC, IGBC, Green Building, Accredited Professional, and 5 times Best Energy Auditor Award for the year 2007, 2008, 2009, 2011, and 2012 at state level, and 4 times National Management Award, SCEM, for the year 2014, 15, 17, 20, and 23. Dr. Subramanyam worked with the National Productivity Council for 20 years in the energy management. Currently heading Siri Exergy and Carbon Advisory Services Private Limited, Hyderabad, as CEO. One of the finalists of the in the Demonstration Marketplace 2006 Global Contest of the World Bank. A CKOH Powder of the Merit Award of Technology Implementation in 2017, and he also got the Sustainability Award in 2020. Regarding to Dr. Subramanyam education, he completed the chemical engineering, graduate from SVU College of Engineering, Tirupati in 1984. Later PG certificate in energy management, the 2 years PG course he completed. And he had this honorary doctorate in climatic change and energy conservation. And other distinctions are BEE Accredited Energy Auditor, ISO 5001 Energy Management Systems Leader Auditor, IGBC Green Building Accredited Professional, and Carbon Footprint Lead Auditor. He started own company. It's a Siri Exergy and Carbon Advisory Service Private Limited in the year 2008, and carrying out energy audits, water audits, carbon footprints, energy management system studies, and providing employment to 20 people. He carried out more than 1,000 energy audits and conducted more than 200 seminars, training programs, workshops in more than 18 countries. And he carried out energy audits of thermal power plants, cement, steel, pharma engineering, petroleum refineries, petrochemical, electricity distribution companies, railways, buildings, hospitals, and also carried out 76 monitoring and verification audit under perform and achieve that's a trade PAT scheme of Bureau of Energy Efficiency. We published out 15 papers in national and international journals on energy efficiency, clean development mechanism, water audit, and etc. He authored a book, Energy Efficiency in the Pharma Sector, published by PCRA. Thank you, Dr. G. Subramanyam Garu, for accepting our invitation. And please proceed, sir. That's section to you.
Yeah, thank you, Srinivas Garu, for nice introduction. And see, my background is mostly energy efficiency, because energy efficiency since almost more than 30 years I'm practicing. I'm a practicing energy auditor. So as I said already, more than 1,000 audits. So different sectors. So my topic will be about more of energy efficiency. Through energy efficiency, how we can able to make it carbon neutral, whatever. Because now there is a target. So target is by 2070. The 2070 you have to make it carbon neutral. So yesterday also Mr. Professor MC Pal, that is Manoj Pal, he was telling about Glasgow. They have a target of 2050 itself. They want to carbon neutral. But whereas India taken as a 2070. So just I am giving just I'm changing the slide. So it is a whatever we are doing is because CO2 is a major culprit. Yesterday also Mr. MC Paul also telling about what are the implications of CO2. So CO2 in India, we have a target of around 35% to reduce by 2030 emission intensity. Whatever all the industries we want to go for 2030 35%, but very not far away, because already we are 25 now. Already another 5 years are left. Next is, what is India commitment? So already I'm telling, is a COP26. Our Prime Minister of India, Narendra Modi, agreed for to make it 2070 net zero by 2070. So this, if we can see, I think it is achievable. Because earlier people are telling it not possible, etc. But the way it is going, so different decarbonization activities are going on entirely throughout the world, and we are very, you can see the targets, we are able to, whatever targets we are able to achieve. So 2070, though it is ambitious, but we can able to achieve it. And many companies in India already, like Infosys or the IT companies, already they are carbon neutral. So through them we can able to learn many things, how they can able to achieve carbon neutral, and many activities are going on in each sector, whether it is industry or it is a municipal sector or agriculture sector, or different activities are going on, like demand side management for the industry or for the energy efficiency and decarbonization. So various activities are going on. I can able to tell about, maybe give some case studies where we have done it and we are able to make it net zero. So for that, first we should know what is the existing carbon footprint of any industry, or any industry, even your say institute. Suppose you have a Jalandhar NIT, there also we can able to quantify what is the carbon footprint. Once we know the carbon footprint, then we can able to devise action plan, how we can able to reduce and make it carbon neutral, depending on the funding available, or depending on the timeline. So anything is C plus O2 CO2. So if you know the carbon content of any fuel, by burning any fuel, we can able to quantify how much CO2 is emitted. So CO2 we can able, this is simple equation. C is 12, O2 is 32. 12 plus 32 gives 44 kgs of CO2. But burning 12 kg of carbon, so there is a 42. So that means per 1 kg of carbon, 44 by 12, that is a 3.67 ton or kgs of CO2 is emitted. So based on that, we can able to find out how much CO2 is emitted by different burning of fuel. So do you have any idea? Suppose we are every one of us using power, because we are talking about this is 5 days going to talk about different ways of utilizing power and utilizing multi-poly generation, etc. So to generate 1 unit of power, what is the, through, suppose we are using a thermal power route. Thermal power, because we can almost 60 to 70% still it is through thermal route. So just I am giving a calculation. Suppose you want to produce 1 unit of roughly we need 1 kg of coal. So depending on this efficiency of the power plant. So 1 unit you need 1 kg. 1 megawatt, 1 ton of coal is required, because now we are generating almost around 2 lakh megawatt of power through thermal area. So that means we need hourly at 2 lakh tons of coal. By burning 2 lakh tons of coal every hour, so what will be our CO2 emissions? So you can calculate, that is a 2 lakh into 3 point, because I already said the calculation, C plus O2 CO2 3.76 into 24 hours into 365, and coal contains roughly around 40% of carbon. So based on that, so we are emitting 2.6 billion tons of CO2 every year. So this is only by the thermal power plants. Apart from thermal power plants, there are many industries use coal, like your pharma sector uses coal, or cement sector uses a large amount of coal, again steel sector. So all the sectors whichever having a boiler, whichever a chimney, so they are using. So this is whatever addition to whatever this 2.6. The 2.6 billion tons of CO2 is only from the power plants. Apart from that, they are captive power plants. So each industry, almost every industry having a captive power plants. So without that, not people are not able to manage, because there is a power cuts. So either they go to for a DC set, or they have to run a captive power plant with a small capacity. So that is additional. So this is the, so
Sir, please unmute, sir. Your voice is muted, I think so. Dr. Subramanian, sir. Please unmute your voice.
Okay.
Now it's fine, sir. I think.
So just I'm giving an example. So simple example is for anything we have to quantify your carbon footprint. For carbon footprint can be done for any of the industry or your organization, your own institute. So for you want to produce 1 unit of power, what is the carbon emission? So it is just giving an example because depending on the efficiency of the power plant, because the supercritical have around 0.67 and efficiency goes to almost around close to 40. But typical average comes to almost 1 kg of coal is required to generate 1 unit of power. Because now we are almost a 60 to 70% of our power generation is through coal route, thermal route. So that 1 megawatt requires 1 ton, 2 lakh megawatt of power out of 4, around 4.3 is our installed capacity. In that 50% we take average depending on the plant load factor. So 2 lakh megawatt we are generating, that means we are consuming 2 lakh tons of coal. So that is, if you calculate what is our emissions per annum. So depending on because we are because it is for hourly basis, because we are generating megawatt means into hours of operation 8670. So if you multiply and also the efficient, that is the coal content in the carbon content in the coal, roughly 40%. It is 2.6 billion tons of CO2 we are emitting. So where all it is goes. So this is again a big is creating this CO2 is a culprit, and it is going to atmosphere and creating a global problem. That is the global warming. So I'm just giving, not only industries are emitting or power plant is emitting CO2, even you and I are also contributing for this CO2. So if you are using a 100 watts bulb, or nowadays even if you are using a 40 watt tube light, whatever, so it is contributing. Even if you use for 4 hours, so we will be contributing almost 120 kg of CO2 per annum. So if you travel by car 300 kilometers, so that is also, it contributes almost 66 kg. If you travel by train, so that is 21 kg, because it is a large carrying capacity. So one way, suppose you got a flight either by Hyderabad, Mumbai, or Mumbai, Delhi, whatever, because it is a 1 hour flight. So 1 hour flight contributes almost 164 kg of CO2. Even if you watch a TV for 6 hours per day, it is our contribution is to 250 kg. Suppose refrigerator, one corner quietly working, it contribution is more per annum. So if you add all this put together, it is contributing to almost 1.22 kg, or roughly it is a 1 ton of CO2 emissions per person per annum, that is per capita. So that means not necessarily CO2 is emitted only by the industries. CO2 we are also contributing either directly or indirectly, because all these emissions are contributed by us. So this is our responsibility to reduce these emissions wherever we are emitting. So we have to identify ways and means of reducing the CO2 emissions, and already we have taken a challenge, that is 2070. So now we are working on it, how to decarbonize, how to make it carbon neutral. This is just because many of you are all learned people, and you are professors and also in teaching field. So you know what is the greenhouse gas effect. So suppose we are traveling by flight. So they will be announcing you are traveling 30,000 feet above the sea level. So they say your outside temperature -40, still you are maintaining a comfortable temperature inside the flight. So why there are 10 feet, 10 kilometer height is because there is a atmosphere. So atmosphere, there is a CO2 is there. CO2 is a God given gift. CO2 is available, and in fact CO2 is a God given gift. In fact, as of CO2, whatever when it takes almost 8 minutes to reach some sunlight, to reach our earth, mother earth, but again entire part is not absorbed, some part is reflected back. So that whatever reflected, again there is a CO2 is there in atmosphere, it comes back to the earth, and by that we are able to maintain our temperature. We were able to maintain our temperature 30 to 35 degrees centigrade, where we can able to live comfortably. Whereas same is not possible in other planets, because we have known planets are there, other 9 planets are there, but this is possible only in Earth. That's why people are able to survive in Earth. Whereas other planets, we don't know there is any life is there or not. So in fact, CO2 is a useful gas. CO2 is there in our atmosphere, that is helping us to maintain our temperature 30-35 degrees centigrade. But problem is we are blaming CO2. So CO2, because there is a CO2 keep on increasing. So but whatever we have shown already activities, it is a lighting or by travel or by whatever burning. So this is a CO2 concentration in the atmosphere is increasing. Because of that, there is a more transmission. That means more reflection. So more reflection, more temperature. More temperature is rising on Earth. So this is called like global warming. So I am giving example. Suppose you are traveling by car, and for suppose you are going for lunch. You are going to your house, and you park it on outside your house, and after lunch again if you go inside the car, the entire car is very hot, and you feel that you have to open the doors and again start again AC. You have to it takes some time. So same effect is happening to our Earth also. So whatever heat captured or it is trapped inside the car it is very hot, so it is not able to escape. So this is happening for the it is like a so we have to find out how we can able to reduce. So culprit is CO2. So CO2 now we have taken the globally temperatures are increasing. As I said, we have in COP26 we have made a decision to reduce it to 1.5. We limit it to 1.5. So for that we have to try. So carbon emissions up to 300 ppm is okay. Up to 300 ppm is used okay. But whereas now we are already crossed. In 2005 itself we have crossed the 300 ppm, and there is a direct correlation. There is a direct correlation between temperature rise and also CO2 increase. So this is and it will go. This is gives the global mean temperature, particularly in the after 2000 year 2000 the temperatures are increasing. So it is a 10 warmest years. In particularly now we are 2025. You can see. So temperature is rising and also CO2 is rising. They are both directly proportional. So this is indicates there is a direct temperature, but we have a data. We have a data since say 1900 data is available. So earlier it is not a single day or a single year. It is a long process. It is a long process. Over in 100 years, our global temperature has gone up by only 1 degree. So 1 degree is nothing. So 1 degree we can bearable, no problem. But if the same trend continues, and the expected rise in temperature is 4 to 5 degrees in this 21st century. 21st century 4 to 5 degrees. Imagine it 4 to 5 degrees increases, what will going to happen? So there is a glaciers. So glacier, there is ice is melting. When the ice melts, again that water joins the sea, and again another glacier. 2004 you can see 1941 it is entire snowfall. When now it is a water. Similarly, another glacier, Patagonia, 1928. You can see everywhere there is a ice. Now it is 2004. Water is there. So you can see 1 year of melt. What is the 1 year of melt? People are doing experiments, research in the North Pole or South Pole. So our people are they put one pole. So when they at the almost ground level, but they went after 1 year. You can see the 1 year of melt. It is almost more than 12 feet. So more than 12 feet ice has melt in single 1 year. So imagine 1 year itself so much of melt. What will happen? So this is happening every second, every minute, every hour. It is happening. So it looks very. If you see the ice melting, ice falling it looks very beautiful. But problem is this is happening. This is so we should able to control. We should able to curtail. Otherwise, our sea levels are rising. So as I said, so for in 100 years, our sea levels are risen by only 1 meter sea levels. With 1 degree rise, only 1 meter. Imagine now if they will to temperature is globally increasing 4 to 5 degrees. 4 to 5 degrees, there is expected rise in water level. Imagine most of the low-lying areas may submerge, and so it is particularly some of the like Andaman, Nicobar, or the some of the thing they submerge in the water, and they may wipe out from our world map. So this is the biggest threat for our Earth. So for that, now the culprit is known. Now we know what is the CO2. So CO2, how it is happening is, now I can give that is creating a greenhouse gases. So greenhouse gases there is a global warming potential. So this is creating global warming. So CO2 is taken as a base. CO2 is taken as a base, that is a base 1, and other greenhouse gases are methane, again carbon dioxide equivalents are there, then NOx, perfluorocarbon, again most of these CFCs are mostly from the our refrigerants. So refrigerants also we have using it in our ACs and also air conditioning system. So then again perfluorocarbons, and then sulfur hexafluoride in our switch gears. So these are we are using it. So this is all different major contributors. So on each there is a, you can see the greenhouse gas effect. CO2 is a major contributor, 56%, methane 18%, CFC is 13%, nitrous oxide 7%, and ozone also 7%. So these are the contributors in our for the global warming, and each having again global warming potential. CO2 has taken 1, methane is 27, then nitrous oxide it is 270. So like that there is a global warming potential. Once you know, suppose that means 1 ton of CFC, suppose CFC is having almost 4,500 global warming potential. Suppose 1 ton is released to atmosphere, by multiplying by 4,500 you can know what is the carbon credits you are going to get, or carbon emission. Whereas methane you can able to multiply by 27, you can know what is the carbon emissions we are getting. Similarly nitrous oxide we have to multiply by 270. So this is the carbon greenhouse gas production we can able to quantify in terms of suppose we want to convert into carbon credits. So now want to make a carbon footprint of your, say, in your campus. So what are they already divided as per the protocol. So as per the protocol there is scope 1, scope 2, scope 3. So scope 1 is mainly is a direct emissions. In case in your campus if you are able to running a DC set, you are running a DC set, or you are using a LPG in your campus, it is a direct emission. So for direct emission we can able to quantify so much is diesel is burned. Then there is a conversion factor. Based on that we can able to quantify how much CO2 is emitted in direct emissions. Then scope 2 is indirect emissions. Indirect emissions in the sense, suppose you are using electricity, because in your say Punjab or Jalandhar, wherever, so you are using say Punjab Electricity Board, whatever. So from there you are getting your nearby power plants are there, number of power plants are there. From that, but it is a indirect emission. You are using electricity, whereas the emissions are in the powerhouse. So that is called indirect emissions. So next is scope 3. Scope 3 is related to like travel, for the travel, business travel. Suppose you are going by for your official purpose. Official purpose you are traveling to say Delhi or wherever you are going, either flight or train or by bus. So that has to be accounted. Suppose you some in the industry there are some transport system, transport raw material getting, again final product is going out. So for that both the play times you are using some vehicles. So there is some your own vehicles, and also there is some outer, there is maybe vehicles belonging to maybe the like Ola or cabs, etc., or the for the transport from the any of the contractor. So contractor vehicles keep going. So those otherwise these are quantified under scope 3. So scope 1, scope 2 as major, and this cannot be avoided. And scope 3 is optional, whether you want, because only thing is because you want to know the what is the how much kilometers you have traveled for your office purpose, by train or travel, those is very difficult unless you have a, even through your TA bill. So through a TA bill, you can able to quantify some extent. So that's why there is a scope 3 is optional. You want to go for it or not. Whereas particularly for IT type of companies, scope 3 is major because most of their activities in outside in either US or in Europe. So for that, so they can able to quantify, and for them is a major contributor. So by quantifying the carbon footprint, I can see which is the major contributor, and how for that next we have to take a action plan, how we can able to reduce. So for that, some of the HFCs, suppose you are using a say ACs. So ACs every year you are doing a maintenance. So you are filling the refrigerant. So refrigerant filling, that we have to quantify because a major minute quantity will be filling. So we have to take from the contractor how much kgs of refrigerant there is whatever refrigerant here it is filled, so that has to be quantified. Next is again you are using a firefighting equipment. So firefighting equipment also some chemical is filled in that, so that also has to be quantified. But this is minor quantity. Major quantity is from your burning. So major is through burning of any fossil fuel. So it is LPG or diesel or petrol. Because why I would talk about travel. Suppose you have a college bus, your university bus is there, then that has to be accounted in scope 1 because you know how many trips it is making, how many days it's traveling, so you know what is the quantity of diesel or petrol used, so those things. Whereas individually you are using car, so that is optional, whether you want to quantify or not, that is optional. If it is a company world or it is a university own vehicles, you can that can be quantified under scope 1. Next is what are the main contributors. So as I said, suppose you have a boiler, because you may be in your campus, maybe boiler may be there for only research purpose, whereas many industries boiler is a must, they will be operating for 24 hours. But whereas DC set will run only for whenever there is emergency, whenever the power cut, DC set will run. And again, gas turbine, suppose if it is a gas based power plant, so gas turbine also runs with the gas availability. And next is transport is a major contributor, because every chimney of a two-wheeler or four-wheeler, it is a potential emitter. Then AC is already said, chlorofluorocarbons, we are using ACs. Then some process also emits CO2. Then fire extinguishers. So fire, as I said, fire extinguishers also some amount of chemical use. Then food preparation, that is canteen. So you have a own canteen or maybe like caterer. So caterer will bring inside, then is not to taken. Wherever you are using a inside campus, you are using some LPG. So that amount of how many cylinders you use, how many cases of LPG is burned inside. So those has to be counted and taken from your HRD department or finance department. Those things has to be quantified, and there is a conversion factor. There are conversion factors. By applying conversion factors, everything will be converted to equivalent CO2. Then what are the possible areas for carbon footprint reduction? So once you identify the source, then it is have to find out how can able to reduce it. So one is energy conservation, energy efficiency. By increasing efficiency, suppose you had earlier boiler efficiency say 80%. You can able to go for 85-88%. Suppose you were a gas fired boiler, you can go up is as close to 90% also. So by that, another one is energy conservation, energy efficiency, that is a major. So with that, by maybe suppose your equipment is very old, so efficiency has gone down, it is a lot of variation from the design and the actual. So we have to find out what is the deviation. For then we can think of going for energy efficient equipment replacement. I am giving just one example of AC. So it's a window AC. So window AC, earlier there is a 2-star, 3-star, 5-star. Nowadays there is an inverter AC. So inverter AC is almost gives a 40 to 50% efficiency improvement. So like that we can able to improve the efficiency of the system. Even we can have some energy gadgets, energy efficiency gadgets are available. Those can be attached. So maybe we can able to go for some variable speed drive. So and it is in inverter AC also nothing but is a variable speed drive. So by efficiency improvement, by adding those maybe retrofit, we can able to reduce and energy consumption and increase efficiency. Next is waste heat recovery. I think waste heat recovery, we are almost going to talk about all these 5 days, how we can able to reduce, increase the waste heat recovery. Now everybody is going for waste heat recovery, either in the power plant or a steel plant or in the cement plants. So we can able to come out because we have recently done some of the audits in cement plants. Wherever we have gone, already people are utilizing already installed waste heat recovery system, and they could able to generate almost 6 to 10 megawatt each plant. Suppose they have a line 1, line 2, line 3, each line they are almost 6 to 10 megawatt people are generating. Next, using green power. So all 5 days we are all talking about biomass, or it is solar or wind. So this is another area we can able to generate and able to wheel power, or suppose you have a rooftop. I think in your campus also there may be already people are using some rooftop solar. This is possible. Next, transport. So transport, slowly we are converting all vehicles to electric vehicles. This already is being done. Then future, hydrogen, ethanol. So ethanol also up to 10%. Now they want to increase up to 20%. This is also the blending. It is possible, so that we can able to reduce our CO2 emissions. Next is video conferencing. So this is again we are practicing. Today itself we are connected to online. Otherwise you have physically you have to assemble and connect this program. So many people coming and attending, and thus also contribute to CO2 emissions. By video conferencing, we are able to reduce our carbon emissions, and this is being practiced by all the IT companies. So IT companies, because there is a major emissions through their travel, so this is they are practicing now online, because now because of either Zoom or whatever the time. Microsoft team, whatever, we can able to meet, and we can able to we can able to complete our task, that is meeting online and discuss and finalizing whatever, reducing our travel time, travel requirement. Then carpooling. Suppose you have this is again practice many wherever some of the campuses the people are practicing. Even in US some lanes are dedicated, some lanes are dedicated for the minimum 3 people has to travel. If there are less than 2 people are traveling, there is a penalties. So the carpooling one thing, so that we can able to reduce our carbon emissions by transport. Then plantations. So plantations again by planting trees, by making greenery your campus. So that also we can able to reduce. So this is also being practiced many of the companies, many of the even campuses. And product design, by changing the design itself, your utility of the equipment, by the automatically we can able to reduce their carbon footprint. So I am just by example, suppose you are using a PET bottle for say 1 liter of your mineral water. So mineral water, it also contributes almost half kg of CO2. By reducing design of the PET bottle, we can able to reduce the carbon emissions. So like that, there's so many things possible. So we have to find out, so which is useful, which is we can able to devise depending on the timeline. Suppose we have to reduce by, so we have a, suppose by 2030 or 2050, if you able to take a target and start implementing all these activities, of course they require investments. So investment has to be justified wherever possible. So another simple example I am giving. So like lighting. So everybody wants to light. So we are using earlier, of course, now many very incandescent lamp. Suppose by even 100 watts, if you are using it for 1 hour, it contributes for 110 grams of CO2. Same LED lamp, we are giving equivalent light and even better light. So better light, that is you can compare with the lux. By comparing lux, you can able to, that is a LED lamp can give more than 120 lumens per watt, or nowadays you can give even up to 200 lumens per watt. So it is 9 watts gives equivalent 100 watts. That means we are directly reducing 90%, almost 91% of energy savings, and also 91% of emissions we can able to reduce. So this is the simplest example by energy efficiency we can able to reduce our carbon emissions. And also the investments. So investment typical, if we calculate, of course, the ordinary bulb may be costing 10 rupees, but LED lamp may be costing 100 rupees. Though it is 10 times, but if you see the life, so LED, ordinary bulb may last for only 500 hours, whereas this is a 50,000 hours. So this is a 50,000 hours is the as per the standard you can able to give life, and the cost we can able to calculate. Suppose if you are able to replace with one bulb we can able to save, say roughly in this case it is 90 watts. So 90 watts we can able to save. So 90 watts, suppose you are using for 5 hours. So 90 into 5, that means 450 watts we are able to save per day. So per 90 50 divided by 1000, that means 0.45 kW, kilowatts per hour per day you can able to save. And imagine for almost 300 days in a year. So that means imagine you can able to reduce, equivalent to of course 0.45 into 300. So that means 150 units. So 150 units average nowadays the cost of power is almost 10 rupees, close to 10 rupees. That means 150 into 10. That means 1500 rupees you are saving, whereas your investment is only 100 rupees. So 100, by investing 100 rupees you are saving 1500. So what is the rate of return? 1500 by 100 into 100 is the your you want to convert into percentage, that is rate of return. So 1500%. Now tell me which business you get 1500% return. So this is the simplest example we can able to quote, so that easy people can able to understand, so that you can able to invest on energy efficiency, so that we can get a huge benefit. Now just I am giving a small about our so we have now we are still 8, another 1 hour is there. So we'll go about the we have already said we are a CDM consultant. Already Srinivas Garu has explained about we have already we are accredited energy auditor. We have got more than 10 times best energy auditor of the year since 2008, and carried out of course 8, and now it is every year because now it is mandatory. And also we are doing implementation of 50,001 even in near to you, that is Chandigarh. Recently we have carried out this MNES, that is energy management systems, that is Nabha Power. Nabha, they have a so supercritical power plant is there. So there we have implemented the ISO 50001, and also we are doing net zero building audits. So we have done already 2-3 audits for NTPC, admin building, there is a service building, and carbon footprint studies. So we have done for HPCL, Midhani, BDL, there is Bharat Dynamics Limited, one is a pharma company, in coal fields, Jindal Stainless Steel. So these are the audits we are doing for net zero buildings, and also for the carbon footprint studies, so that we can able to make them net zero in future. And this is my certificate about carbon footprinting. And also now there is a again lead auditor course for ISO 14064, like 9001, 50,001, 14,001, like there is a for the carbon footprint also ISO 14064. So carbon footprint, I am just giving you an example where we have done coal mining. So coal mining, that is a Northern Coalfields Limited. So they have 10 mines. So 10 mines, they have we have done the carbon footprint. Then scope 1, scope 2, scope 3 identified. So based on that, the total is total. So total carbon footprint of these 10 mines. So mines major contribution is again they are using a diesel for dumper dozers, because a lot of transport they are using it for mining purpose. So then scope 2 is electricity, scope 3 is travel. So travel, everything is quantified, and based on that their carbon emissions are coming on somewhere around 6 lakh. Around 6 lakh per 6 lakh tons of CO2 is their CO2 emissions under in baseline. So we have scope of work. My scope of work is to give an action plan, and after again 2 years, again we have done the post audit. After post audit, so again we quantified after post audit what is the reduction achieved. So they have reduced almost so 1,20,000. So 1,20,000 of yeah. I'm audible, sir.
Yes, sir. Yes, sir.
So we have this mining industry, that is northern coal fields, able to reduce 20%, 20.8% able to reduce in 1 year period. So there is a huge, so 1,20,000 carbon emissions. So that can be even they can gone for carbon credits also. But being a public sector, so they could not able to convert it. So this again we can able to quantify and able to show the savings. So show the reduction in terms of carbon footprint, not only in paper, we should able to show based on their bills, electricity bills or consumption. This is the so much of reduction they would have achieved, and these are one of the good case study to showcase. And the steel plant, for one of the Jindal plants, they have quantified. Again, what are their main emission sources? So emission sources, they have captive power plant. So captive power plants, that is a major captive power plant. Again, they are using coal. This is in Orissa. Again, they have a APC boilers also there. In the process team, they are generating. Again, they make coke. For that, again, there is a carbon emissions. Then coal combustion in ferroalloy plant. Sir, can you, so can you, can you unmute?
పెట్టు లైన్లో పెట్టు.
To mute other self.
So they have a petrol diesel consumption in transport, emissions from air conditioners, emissions from firefighting equipment, emissions for vehicles used inside the plant for material transport, and also power import. Because addition to their own generation, sometimes there is a power cut, they have to import. So that has to be accounted. Then air travel. So see all this contributing for major emissions, they have quantified. And again, it can categorize into scope 1, scope 2, scope 3. They quantified. So this is quantified. So you can see scope 1, scope 2, scope 3. Of course, we have done some 4-5 years back. See what is the total emissions? GHG emissions. Here it is almost 24, almost 25 lakh. So 25 lakh tons of CO2 is being emitted every year, and under this is the scope 1 is major. 95% is scope 1. So scope 2, because their power is they are getting from outside, that is imported power. Though they are generating power, so for that it is a coal is used. So that means that coal is inside they are burning it, so it comes under scope 1. Whereas scope 3 is nominal. Whatever scope 3 travel, there is a nominal, so it is a 0.01% that can be neglected. So by this we can able to know which is the contributor scope 1. So for scope 1 we have devised, we have told them what are the action plan we have given. So action plan, so this is a total carbon footprint of this company is around 25 lakhs. Then SMS production, because you have to quantify in terms of single per ton of production. So per ton of production, total employees are, you can able to quantify. Suppose in case of your campus, so campus we can able to quantify in terms of number of people staying, either faculty or the students, we can able to quantify. So whereas here you can quantify per ton of production. So per ton of production is coming to 2.8 tons of CO2 per metric ton of production. And specific emission per person is coming to almost 300 tons of per person. So whereas there is a steel international steel. So international steel, what is the international norm? international storm is 1.85. So there is a mark, whereas these people are at 2.8, whereas international norm is 1.8. So that means there is a scope for improvement. So by this, like this, we can able to see there is what is the margin. So in our case, we have given a some, because I cannot able to reduce total. So what are the possibilities based on our audit, and also we have given so equivalent, because we have done the through energy efficiency. Energy efficiency, we have given an action plan to reduce almost 50,000. And in terms of that MTOE, that is metric tons oil equivalent. So metric ton oil equivalent, even this has been signed by those people. As energy auditor, I have signed. As the energy manager, their energy manager signed. So based on that 50,000 equivalent, we can able to say reduce in a 1 year period. And there is a equivalent we can able to convert. So roughly 1 ton of oil equivalent to 3 tons of CO2. So you can just simply multiply by this. That means almost 49 to 1.48. Then through plantations. So plantations, we have quantified how many plantations that have been done. However, what is the growth every year? Based on growth, we have quantified how much carbon sink is being created. So total 1,51,000. That means what is the production reduction? 7.36. So what we can able to, because this is possible in the steel industry or cement industry, where you can't give a carbon neutral. That means they totally they cannot do it. They have to go for a, maybe they have to buy green power, then can able to make it carbon neutral. So on their own, they cannot able to make it, because nobody can able to produce steel without a carbon, without power generation, etc. So this is a possibility. 7 to 10% is possible. So this is being already they have implemented, and able to achieve sometimes very close to this. I'm another green building. I'm giving another, because one I talked about mines, second is the steel industry, next is the building. So this building again is applicable to you also. Your campus also possible, because depending on your square feet, what is this area of your garment. So what units consumed, so per day, so one of the building, they consumes almost stage 1 consumes, that means roughly per day it is almost 1500 units. 1500 units per day, the consumption per day. And also number of days working, so 300 days, number of holidays, again working on holidays, what is the load, the non-working days consumption we have taken, suppose in your case Saturday, Sunday, in annual consumption we have quantified and converted, because there is a every year CEA, Central Electricity Authority, publishes the CO2 emissions, because not only coal, because we have a nuclear, we have a solar, we have a wind. So nowadays biomass very nominal. So those things, because it's a mix, energy mix. So based on that, we can able to quantify what is the emission factor. So emission factor, of course, this is 0.82 that was on during earlier. Now this has come down to almost 0.73, because efficiency is improving. Efficiency improving, we are adding more and more solar to our grid. So that's why emission factor is coming every year. Earlier it was a 0.82, now it is only 0.75 or 0.76. roughly. So annual emissions we have quantified only 368 tons, but 368 tons is very nominal for a building of a they have a cap, they have a service building, small building. So we identified we can go for a internally put for some solar, and this is we try to reduce by energy efficiency, whatever ACs are there, whatever lighting is there. Through that we have given a action plan. Suppose this is the, we can able to make it net zero. So we have given a use energy efficient fans. Nowadays in the market there is a BLDC fans. By that, how much can it reduce? Energy saver flood AC plant. Energy saver for solar by solar major country we can able to reduce. Replacement of old ACs, cost economic using some, suppose for conferences or etc. We can able to go for a skylight. By putting a skylight, we can able to reduce your power consumption daytime. So whatever daytime you are working, you can put a skylight. Then delamping or corridors, wherever there is a lux levels are high, we can able to reduce this by that stage 1, stage 2. So total put together, though they are having an almost 398, we have given an expected CO2 emission reduction close to that. That means they can able to make it net zero just by implementing some of the options. So now, any doubts so far, so that we can able to give another study recently we have done for one of the pharma companies, some of the pharma companies under decarbonization. So Government of India now, through under Bureau of Energy Efficiency, recently brought out, because earlier we are doing whatever PAT, that is perform, achieve and trade, and converting into carbon, equivalent metric ton of oil equivalent. Based on that, one oil equivalent to one energy saving certificate. Now in future, now all we are going for a carbon credit trading scheme. So whatever carbon credit is our internal, earlier it was a for the international, whereas this carbon credit, there is a PAT scheme, perform, achieve and trade scheme, was not there for only for India applicable. So that the Bureau of Energy is converting to CCTS, and also the framework has been created, and shortly, so they are going to announce the targets, because already under CCTS the baseline audits are over for a number of sectors, and they are going to give a target. Once the targets are given, again they will be given some time frame, maybe 3 to 4 years time, they should be able to reduce, otherwise they have to pay penalty. So penalty is going to be huge. Nowadays 1 ton of metric ton of oil equivalent, the cost government has fixed is 18,402. 18,402 is the maximum price, and of course this is again depends on the market trading. So depending on the market, it will keep fluctuating. So more sellers nowadays, there are more sellers are there than buyers. So that's why it is as reduced to low now. But minimum cost is 1,000 rupees. For 1,000 rupees for 1 ton of metric ton of oil equivalent, and that is 1 metric ton equivalent to say 3 times carbon credits. So this scheme is going to come shortly. So I'm just giving, because we are talking about all power plants, because power plants we have done almost more than 60-70 thermal power plants audits, and because it all depends on the heat rate. So how you can able to increase the heat rate? So one is by reducing the heat rate, there is a direct saving. So direct saving for you can able to reduce your coal consumption, and is a direct benefit. But under PAT scheme, that is perform, achieve and trade scheme, so by if you able to reduce 1 kilocalories per kWh, so for a normally heat rate of a typical power plant I am giving here, it comes to almost 2,500, roughly 2,500 for under a net heat rate is 2,500. Suppose by whatever means, whether you reduce your increasing boiler efficiency or reducing your auxiliary power consumption, wherever you can able to, or you can go for a future some waste heat recovery, whatever you do, you able to reduce even 1 kilocalories. What is the advantage? Because from 2,500, if you are able to 1 kilocalorie reduction is very easy. So assume there is a typical generation of 10,000 million units per annum, and if you are able to reduce 2563 from 2564 to 2563, that means you are reducing only 1 kilocalorie. So 1 kilocalorie also makes lot of difference. That gives you 1,000 energy saving certificates. 1,000 certificates in carbon credits, it comes to almost 3,000. So what I already told, one cost of energy saving certificate is 18,402. That means they can able to get a benefit of 1.84 crores is an additional benefit, like incentive. So one power plant can able to get just by reducing 1 kilocalorie. In fact, as per the recent the PAT, you can see the document, PAT Gazette. Gazette is available in the Bureau of Energy Efficiency website. Many companies, their targets are varying from 20 kilocalories to even 100 kilocalories. So 100 kilocalories they have to reduce. Imagine how much they have to put effort and how much of incentive they can able to get it. So this is some of the companies, they just by selling energy saving certificate, they got almost 10 crores revenue. So that 10 crores they are dividing as an incentive to all the employees. All the employees they are giving, because of it is a combined effort of all the people. I'm giving another example. Suppose in cement plant also same. So they convert kilocalories per, not kWh, this is per ton of cement production. Per ton of cement production, what is the metric ton of oil equivalent? That is 0.0, or it is equivalent to 699 kilocalories. 699 kilocalories of energy is required to produce 1 ton of cement. Suppose if you are able to reduce it to 698 to 698, that means this company having a production of almost 41 lakhs of cement they are producing, And this is all actual figures. I am not theoretical. This is all based on the Gazette. The Gazette of India and their actuals I have calculated. So they can able to reduce by just by 1 kilocalorie, they can able to get energy saving certificate of 410, and at 18,402 they can get benefit of 75 lakhs as an incentive. So this is a as an incentive in case if they don't produce or they don't reduce, so there is a penalty also. So heat length penalty also there. So that is we have to use it for the benefit. So PAT is says you can able to use it as a both as a reduction and also as a tool for imposing penalty. If they don't pay a penalty, and it will refer to, they will be given, it is a given non-conformity, and non-conformity they have to submit, they have to buy from the market. Suppose there is a shortage, suppose it is negative, instead of that positive there is negative, so many 410 of energy saving certificate they have to buy from the exchange, that is IEX, Indian Energy Exchange. So Indian Energy Exchange, you can able to buy or sell all these. For that you have to register, and you can able to buy and able to show they have meet the non-conformity by purchasing. There is no other option. So suppose you are suppose you are also having a NAC accreditation. So NAC accreditation, you may have so many non-conformities. So your energy audit is not being done, or water audit is not done, environment audit is not done. You are not taken training. So for all these things can be just by conducting a training, you can able to close it. Suppose some instrument is there, there is not calibration is not done. So you can able to get it calibrated, and you can close that non-conformity. Though all this can be done by spending some money and amount, a small amount or a can. Whereas here there is no other method to close non-conformity. You pay penalty. So whatever you are showing here penalty, it comes to huge lakhs and crores. That amount has to be paid and has to pay, that is closing non-conformity. So I am giving another example. Suppose a distribution company. Suppose Punjab, there is a Punjab PE, Punjab State Electricity Distribution Company is there. So they have also targets. So they are typical. So 14.44 is the T&D loss. That is transmission distribution loss. Though this can be again you can able to check from the Gazette. So this is a 14.44. Suppose they are able to reduce 1%. 1% they are able to reduce. That means 14.44 to 13.44. So how many equivalent tons of oil equivalent they can able to reduce? 15,000 equivalent energy saving certificate able to get it. Tons of reduce. So here equivalent energy saving certificate, not this one, ton of reduce. This is a 10,224. So 10,224 of this is their baseline. This is the target. If they able to go below the target, they can able to get 10,224 energy saving certificate, or in terms of rupees 18.81 crore benefit they can able to achieve at higher rate. So but minimum rate is 1,000 rupees. Even at 1,000 rupees, if you can calculate, they can able to get almost 1 crore. So 1 crore easily can get a typical discount. So maybe Punjab may be divided into north and south are typical discounts. So
Sir, please unmute, sir. Please unmute.
I don't know.
Now, thanks. Okay.
So I'm giving just an example for a discount. So even 1% of T&D loss, if you reduce 1% of T&D loss, if you will reduce, so you can able to get a 10,224 energy saving certificate that equivalent to 18.81 crores of rupees as an incentive, and even at 1,000 rupees, that is minimum market rate is 1,000. Even at 1,000 also you can able to get almost 1 crore benefit. So this addition to the whatever benefit by so much of 1% is equivalent to so many of million units if you are able to save, that can be sold to the higher tariff, that can be sold to industry higher tariff. So that is additional advantage to a discount. So that like that I have just given an example how much you can able to So I'm just giving because one is what I told you. We have another how much time? So still another half an hour time is there. So I'm
Yes,
giving
half an
it.
hour.
So this recently we have done. Recently we have done because everything is we are converting into carbon. Whatever energy savings, everything we are converting into carbon and showing as what is decarbonization is taking place. So is a we have implemented. Can I go ahead?
Yes, yes, sir. Yes, sir. You can proceed, sir. Yes, sir.
This is a pharma cluster in Vizag that is very close to Visakhapatnam in Andhra Pradesh. So we have implemented in 5 of the pharma companies. Under this is again sponsored by Bureau of Energy Efficiency and also AP State Energy Conservation Mission. So recently we have done the post implementation workshop, dissemination workshop, and we have given our what are the baseline, what is the how much actually we were able to save and because one is doing energy audit only in paper, we will be able to show you can save 20%, 30%, but actually it is really possible or not. So we have done the dissemination workshop recently and see what is happening. So this is a typical chemical plant. These are pharma companies. So pharma companies, we have quantified what is their KWH power consumption, etc. Suppose this is a typical company per month they are consuming almost almost 4.5 lakhs. So in your case also, you may be in your campus may be consuming more than 2 to 3 lakhs, 2 to 3 lakhs per annum per month. So that can equivalent to almost whatever I don't know, maybe minimum 10 lakhs power consumption may be there. So this is where all it is going. So energy audit, we can able to quantify where are the major contributors. So utility means again mostly it is air conditioning. So in your case also campus. So campus also major contributor is your ACs. ACs either central AC or window ACs. That is a major contributor. Next is your lighting. Next is your lifts. Next is your pumps because some water pumping may be doing in your campus. So that is, and also your hostels. Hostels is again same lights and fans. So in maybe in admin building, wherever you have so all the fire hydrants. So fire hydrants, but they not be running continuously. Then ETP or STP, effluent treatment plant for your sewage treatment plant. This also be the typical any plant, any company, any industry or any campus, it will be there. So those are the things we can quantify and give a example or a percentage. So that is nothing but we can able to do and see quantification. So quantification you can easily show what is 60%. So major contribute is 60% utility. So our concentration also on utilities. So same thing is projected in terms of 60% in terms of pie diagram. Next is again we quantified that we have quantified in terms of carbon emissions. So carbon emissions is coming. What is electricity, diesel, coal? These are major fuel sources. So that converted into GHG emissions, it is coming to almost entire these energy consumption bills based on bills we quantified. It is coming in terms of rupees. The total bill comes to 1252 crores in that area. That is almost 90 units are there. So 90 units they are converted and it is a contributed is almost 14 lakh 60,000 tons of CO2 is being emitted by only one cluster. And what are the to reduce those emissions? So we can identified some technologies which can be done so that we can able to showcase, we can able to reduce. One is the variable speed test because chillers because any pharma companies they use chilling either -10, -20, there's +5 degrees etc. They use different applications. And for chiller means again there is a compressor. There is a refrigerant compressor. There is a major contributor. So addition to chiller, there is again pumps. There is a primary pumps, secondary pumps. Then there is a cooling tower. So these are associated equipment. Then another equipment we identified is the FRP blades for cooling towers. So there we identified another is air compressors. So air compressors again utility, major utility or any company. Yeah, I don't know. Even if you go to your campus also, there will be air compressor in your STP or ATP, or even if there is even a hospital, even a hospital also, yeah, there is air compressors for the ventilation. So there is a air compressor will be there. in micro turbine in place of PRDs, wherever they are people reducing pressure, PRD is one of the option we identified. By VFD for ID fans, energy saver for AC plant, solar rooftop. So this is identified, but based on the funding available, because this is implement, because we have a limited funding. So based on that, we are implemented only. So as per our scope of work, we are able to showcase some 3 technologies. So 3 technologies we have to implement and show savings. So first one is we are chosen as a chiller as one of the option. So chiller we have implemented. So chiller you can see here, this is a voltage chiller. So voltage chiller, this is the typical, earlier is a start at a starter. So start at a starter, we are replaced with this VFD. This is a VFD. So new VFD addition to just disconnected, and next to that we have implemented. So I can see the myself standing. So all the recently we have, so can even there is a, you can see the geotagging, because this is a government sponsored project. So they asked us to show where I implemented. So they can able to, we have given a geotagging, we can able to latitude, longitude, so that we can also pinpoint where exactly we have implemented, and they can able to, anytime they can able to go there and able to see whether really savings has achieved or not, so that they are implemented or not. So we have implemented this saving, and we have quantified, and we have people have signed. So VFD, by just implementing VFD, there is an energy saving of 18.33%. 18.33% based on the actual KW basis, KWH basis. Addition to that, we have showed them for TR, ton of refrigeration. But KW earlier they were getting 1.4 because it is a -5 degree. -5 degree they are operating, and same conditions, say same conditions, we have got under KW but TR they got 15%. So all of us are signed. They by the supplier, and also by CREX we have signed, and also by the user, that is the Innovator Labs, they have signed. All the people are signed and showed them how much saving they really got it. And also we have showed them what is the payback period and all. So we have invested around 5 lakh rupees. We have invested 5 lakh rupees for that VFD, and payback period is less than 1 year. So less than 1 year means what is the rate of return? So rate of return is more than 100%. More than 100%. And see the load. This is a VFD for the 180 kW. So 180 kW motor we have replaced, and actual saving is almost 15%. And the power tariff is cost of energy is 7 rupees 18 paise. 7 rupees 18 paise was the unit cost. So based on that we quantified and showed these are savings. Another one is we have again cooling tower is another major utility. Most of it is international. Even your campus there may be some cooling towers, centralized AC. There are cooling towers, and also so there is earlier they are having a aluminum blades. Aluminum blades we are replaced with the FRP blades. So again we can see these are the blades. Again myself I climbed, and so this is again the latitude, longitude. You can see in another unit you have implemented, and so this is the geotagging. With the GPS map camera we have taken, and savings. Can you guess what are the savings we got for just by replacing the fan blades? We didn't replace any motor. Same motor, earlier motor, same motor, only fans replaced. So you can show here. So we have a saving of energy saving is 23%. So 23% saving we got, and also additional, because by replacing this fan there is an increase in airflow. So airflow was increased. This is a 17.54%. So this is additional benefit. So additional benefit, there may be additional benefit in terms of savings in the chiller, but we could not able to quantify. We could not able to quantify the actual benefit because of increase in air. So this is, so same thing again we have. So we can able to see here. This is again third part. All the people have signed. So this is implemented here another. So in terms of 17.5% increase in excess air and power saving 25%. So this is the actual saving we got in one of the another pharma company. This is another SSV Pharma. The company name is SSV Pharma. Earlier we implemented in Innovator. So this is another technology available in the market, even from the Amazon. Amazon also you can buy it. So they are claiming 35%, even up to 50% saving from your split AC. So split AC, this is again we bought some few pieces from the market and we have installed. This is a 1.5 ton AC we have implemented. So my person is we are using the energy meter. We are connected energy meter also. So because for the individual, so we have a bought energy meter even to connect to one fridge or a, because otherwise very difficult to know the savings, because it is sometimes it is in watts only. So no energy meter will measure watts. So we bought one energy meter separately and installed so that we can show we run the AC without AC is a energy saver, and this is the energy saver. It is connected. It looks like a small stabilizer, small stabilizer, and also with the display and implemented and showed savings. So by this we got almost in peak summer. So peak summer here also you can see day and time. We have peak summer we have implemented. Here also we got almost 16 to 17% saving. So 16 to 17%. This can be done even for your house also. In our house, whenever any area, in fact we have demonstrated and we have it got signed. So like this, we have implemented in some of the FR blades, some of the FRV blades, and also VFDs, and also the energy saver, and you can see the actual savings, and what is the investment made, and overall the saving, this payback period less than 1 year. So 1 year means is one. So you can say 1 by 1. It is a 2 years means 1 by 2, 50%. So it is you can see 0.7 means your rate of return. So rate of return is 1 by 7. So this is 1 divided by 0.7. Almost all 142%. So 142% very good investment. Even if you put in a bank, nowadays banks are giving hardly 6 to 7%. Even if you are a senior citizen, they are giving another 0.5%. So not more than 8% we are getting. Whereas by investing energy efficiency, you can get a returns of more than 100%. So this is the practically shown, and we have quantified. Suppose the entire cluster, because I showed what is the entire cluster, how much they are able to, if you are able to, because we have invested only few lakhs when 4-5 units implemented. Actual savings, so we have showed. So there is a possibility of minimum even 5%, because I cannot make it carbon neutral. Even this is actually 5% you are reduced. By reducing 5%, how much tons of CO2 can be saved in one single location is 51,000. So 51,000, almost like close to 52,000. So 52,000 by just investing, you can able to invest almost 6 crores, 600 lakhs. I mean 6 crores with less than 1 month period. So we have demonstrated 5 units and showed the sponsor is Bureau of Energy Efficiency and also AP State Energy Conservation Mission. And by just spending 6 crores, we can able to reduce so much of energy by simple demonstrated projects. By implementing only 4 or 5 projects, not necessarily solar is another project, but solar is investment. So there is requires a huge investment, and they may be going their own, because this is sponsored project. We have invested our own and showed savings, and same thing in terms of. So there is an actual 5 units around 20% we have showed, and if you can extrapolate, because all units cannot be implemented all the same thing. So average 5% can be saved, and there are around 52,000 tons of CO2 carbon can be reduced. So this is practically shown. This is practically shown to the one of the pharma cluster in Andhra Pradesh, and and maybe it can be replicated wherever similar units are there. It can be replicated. In fact, we have done similar study in Jalandhar in one of the engineering industry, particularly the forging industry. Earlier we have done some studies in Jalandhar itself, and Patiala, Jalandhar, those areas we have done earlier. And so what I'm going to do is, because whatever I shown, it is actually practically we are showing them, we are implementing and showing. In fact, afterwards, we are one of the cold storage. So cold storage also we have recently implemented and showed saving by replacing the cold storage. Again, there is a major contributor is the chiller. That is, they use ammonia chiller. So ammonia chiller We have, in fact, one of the company even replaced. So a chiller was running under based on the gasifier, because they are having a, because in some of the areas there is a rice husk was available. So rice was converted to gasifier, and gasifier producer gas was given to gasifier, and through gasifier that gas is given to DC set converter. But after some time they found a lot of problem with the torque. They again they replaced it. So what I am going to tell is, there is always scope for improvement, and where there is a targets, and also government is strictly implementing, and we have to make it net zero by 2070. Otherwise, there is a huge penalties and also incentives. So we can able to save energy, save our planet, save today, survive tomorrow, and also get additional revenues, because just by not only spending, I also can get an energy saving certificate either through e-certs or carbon credits. So carbon credits also possible. You can able to convert, and in India already the scheme is going on. Suppose you have carbon credits, you can able to sell in the market, or through CCTS, that is a carbon credit trading scheme. In future, you can able to get carbon credits once you able to do it. And thank you for giving this opportunity. Thank you, Srinivas Garu, for giving, and also the NIT Jalandhar. You can able to reach to us for any of your requirement, not only for energy audit of your own campus, or you want to go for a nowadays NAC registration also. NAC want to get a rating. So this energy audit and your water audit, environment audit. So we have done for some of the universities. Some of the universities we have done recent, and they got A plus plus, because they have some points are available for this. So our energy audit or whatever, so that gives a really benefit. So any doubts, any questions, you are welcome.
Hello, sir.
Yeah, tell me, sir.
Myself, Dr. Manish, working in CPSED as an assistant professor. It is a college of some industry, which is testing center of plastic. The sectoral organization. So my question is regarding that you have changed the blade. So have you changed the design in the blade? What type of design you have made the changes? That you have changed in the cooling tower without replacing the motor. You are saving around 20-25% energy.
Yeah. Yeah, this is practically shown, because we can see we have ourselves procured it and replaced and showed saving not only one location, 3 locations we have done it. 3 locations we have done it. So one location 25, another location 28. So that may be, but always this is saving is more than 20%. This I am giving with investment of only 50,000 rupees. So one blade want to replace is only 50,000 rupees. So everything can be done. So that is what we have showed. That is a one thing. Another chiller, of course, VFDs. Another place we have showed some ACs. ACs we have put a energy saver without replacing the existing old AC.
My question is that what the change in the blade design? Is there any blade design or material change only, the weight change?
Sir, it is earlier it is a aluminum blade. We are changed it to FRP blades. So FRP blades, it is a given a lightweight, and also it is a you can say a CAD cam. It is a computerized design they are used, so that we can able to profile improve, the friction loss reduce, and given a higher airflow and reduce power consumption.
So no, my question is regarding the profile. Profile of blade, the profile is same. You have replaced the blade with the FRP. But my question is that have you changed the profile of the blade? Or the both blade is having same profile?
Sir, I am not manufacturer, I am not a designer. I am procured from the market, which has given earlier they based on some cases of they said already replaced. So my as per my scope of work, my scope of work has to reduce their carbon emissions and showcase decarbonization, because unless you show savings, nobody going to believe it. So we are so much of research you do, unless it is practically implemented. So there is no, okay, because so many, because since beginning, because FRP plates also not new. So there are so many changes, design changes. So I have procured from the market, from Mumbai. I procured it, installed it, and showed saving before and after. So this is, I don't know what is the design they have done it. So I have based on my budget, I have procured and showed saving in five locations, not one location, 5 locations.
Thank you, sir.
So any further questions related to carbon footprint or carbon reduction or carbon credits, or any related to energy efficiency in any of the system, any of the even power
One of
plants?
my questions, sir. Hello, sir. Sir, in India, which city is producing most carbon footprint and the least carbon footprint among the cities? I am not talking regarding the rural areas. I am talking regarding this city, in terms of cities.
सर सिटी के लिए again population ना population ले लीजिए, which are population most that will be, because we didn't have a data about each city. So I have a data about industry. You talk about any industry, power plant. So power plant, I have already told, you produce 1 unit of power, you are contributing almost 1 kg of CO2, roughly 1 kg. Suppose you are producing say 1 ton of steel, I have a figure, it is contributing to 2.8 tons of CO2. Suppose you want to produce 1 ton of cement, so it is contributing almost 1.8 tons of CO2. So like that I can able to give a figures, and these are actually practical figures. So like a city, which city I cannot able to give. So there is only for India, entire India, there is figures are available. I know per person. So per person, per capita, if you take, we have 140 crore people. 145 crore people, I have a data. We are contributing almost 1 ton of CO2. So 1 ton of CO2 in India, whereas US it is 25 tons, because their consumption is 25 times higher than us. So like that figure I can give, not for a city wise.
Okay, sir. Thank you, sir.
So world average is 3.3 tons. World average CO2 emissions per person is 3.3. So we are below average. But problem is we are increasing the bottom denominator. Now it is number 1 in population, and we are showing the numerator dividing and giving a figure of around 1 ton. So that is that's why now Trump also is he says nothing doing. You also is come out of the Paris Agreement, and he says you are polluter third. We are third largest producer or polluter. You pay for it, because as on today we are only seller. This carbon emission, carbon credits, we are seller. He says in future we become a buyer.
Yes, anyone else? Sir, there is one question in chat box, how to calculate carbon emission compressor.
Sir, I already given. Suppose this is a CEA, Central Electricity Authority, every year publishes sir, for India. For India, it is a mix. Electricity is being produced from coal, oil, gas, and also nuclear. Then nowadays solar, wind, all these things. Based on that, there is a mix. By mixing all this, what is our common emitter that comes to now almost all. Earlier I showed in 0.82. Now recent 23-24 data is available. 23-24 data shows it is a 0.75, almost 75. That means if you produce 1 unit of power, our CO2 emissions are 0.75 kg. So by that you can quantify. Suppose you want to do for carbon emissions for your house. Suppose you want to do for your house, so you can able to quantify how many units of power you are using, so that can be converted. Suppose for you are using LPG, how many cylinders of LPG you are using per month. So cylinder, one cylinder is 14.5 kg. So 14.5 kg, you can convert to, there is a emission factor, there is a IPCC, International Panel on Climate Change. So the IPCC also published these factors. So once it is published, though they won't change, because we want to burn 1 kg of coal, burn 1 kg of petrol, 1 kg of diesel. Those values is constant, whereas electricity only change. Electricity will change depending on the power mix, and also it will change country to country. Suppose you go to take a Nepal. Nepal is mostly hydel, so their emission factor is very low. Similarly, you go to France. They are producing from nuclear, so their emission factor differs. Though it is 1 kWh of power. So like that, we can able to quantify. There is a values are available. If you give me values, there is a simple Excel sheet. We have already devised. Those is available from the net. So we can quantify and able to convert it to equivalent CO2. You can do it carbon footprint or energy it for your own house. You can do for your own house, and we can see, we can take it. In fact, I have done for my own house. What is the energy consumption? I am able to reduce 35%. So I have published my home energy audit. I have published a paper on my home energy audit. So 35% is a huge reduction. So in fact, that is available in one of the, we can able to search for it.
So thank you, sir. There is another question in chat box. How we can achieve net zero target as demand for power and CO2 emissions are increasing?
Sir, that's why, sir, I had already showed in 3 companies, 3 typical industries. One, steel industry. So steel industry, I could able to save only 7%. So by 100%, we cannot make it. So you can't produce a steel without any raw material. But to make a raw material, we have to transport whatever iron ore, right from the, again, we have to do the, right from the beginning, right from main mining, transport, all these things you have to quantify. So for that, they cannot do it. In case not able to do it, we have to buy from market. Maybe you have to, instead of a green power, you can utilize and neutralize. Similarly, suppose in your campus, you are using say 1 lakh units of power. So 1 lakh units, you cannot able to make it net zero just by putting as 100% solar. But solar is only available in daytime. For that, you have to again make a, maybe now in future, battery energy storage system. For that, again, it is a huge costly affair. Whereas solar power plant, maybe you can able to put 1 megawatt, maybe 3 crores. Whereas you want to put a solar battery system, it requires another double, 6 crores per megawatt. So those are the things we have to see feasible options. You have to come out with the feasible options to make it zero. So it is a slowly you can able to do it. Whereas I already showed like Infosys already they are a net zero. Infosys already net zero. What they have done it, they have done through energy efficiency something. Again, they have done for a solar and they are for plantations and whatever balance they are themselves implementing in solar power outside and they are wheeling power. So wheeling it power and make it net zero. Make it net zero and always some people are even not net positive also. Like water also you can able to conserve and able to make it and recycle, reuse like that. Here also you can able to energy can conserve it and also some production possibility is there, but all the place not possible because the steel plant they can't put a rooftop in their power plant, their steel plant. Whereas your campus is there, so you have some extra land we may have available or rooftop may be available. For there we can able to do it.
So thank you very much, sir. Yes, Professor Srinivas.
Yes.
Okay. So can I now give deliver the vote of thanks?
Yes, please proceed,
Sir,
Dr. Rajan Kumar.
I request you to share the sessions. It was very
Yeah, this
insightful
PPT,
session.
sir,
Yes,
this
we'll
PPT,
share the PPTs. Yes.
share with Srinivas sir. You can
Yes,
able to
yes.
have it.
Yes. I will share the participants. I received a presentation. I will share to all the participants.
Also, sir, there is one request in the chat box. Please share your email ID.
Okay, sir. I'm just writing here. Even my presentation it is there, and I'm again sharing here. See that my company name is AICTE-ATAL. Of course, my though it is another email is there, Subramaniam@AICTE-ATAL. There is some problem with that. I am giving the Gmail. So Gmail address I am giving. So anytime you can able to reach to me and anything related to energy efficiency, carbon credits, etc. Because my company name itself AICTE-ATAL Carbon Advisory. So since 2008 we are working in this field and we can able to, we are helping industries to reduce their carbon footprint.
Thank you very
Sir,
much, sir.
does your company also provide internship to the BTech students?
Can you, sir, can you repeat again?
Does your industry also provide
So internship for BTech, sir, is asking
Okay.
about the BTech internship.
Yes. Yes, sir. Some people earlier came from VIT. With some students came and they because in the office we are not doing anything because most of our projects are in the field. Like I said, we are done for the Nava Power in Chandigarh. We have done some audits in say Jalandhar, some cluster there. So like that we regularly because almost every month we are doing 1 or 2 projects because this is mandatory requirement. So we can able to send them as a practical they can able to come to the office only for writing report. So we almost 15 days out of station. So myself will travel out of station majority of time. So because audits you have to can't do in sitting in office. So you have to go to the field and show saving because they are paying for it. So they are paying for it. So they just we can't show just only some report I cannot be able to give. Nowadays that has to be signed by and also vetted by Bureau of Energy Efficiency and also there is by the state designated agency like Punjab it is PEDA, Punjab Energy Development Agency. So like that Gujarat there is a Gujarat Energy Development Agency. So they, again they scrutinize whether my report is feasible or not. So just like that I cannot give options. You go for solar, you replace your lights, you replace your fans. Like that I cannot give general suggestions. So I had to give with the cost implications, how much it is possible in a year. So those things. So again, afterwards they had to produce again a action taken report. Again, just I'm giving action plan now. So after 1 year, they had to go submit the action taken report. At that time, they say I have given a useful, that is a useless report. They could not able to even fill out even one single session. Then credibility problem and also then B also says even they blacklist us. So that's why we should be careful in giving suggestions which is implementable only.
Thank you very much, sir. So can I deliver, sir, vote of thanks
Yes,
to
yes, yes, yes.
Dr. G. Subramaniam?
Yes, 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 yes. You can, Dr.
Okay,
Rajan, you
so
can.
yeah. So I feel honored to extend my heartfelt thanks to Dr. G. Subramaniam for delivering such a insightful lecture on energy efficiency and carbon neutral work. So your talk has helped us understand the importance of energy efficiency and how we can work towards a carbon neutral India. The ideas and solutions you shared were truly inspiring and have given us a lot of lot of given us a lot to think about. On behalf of Department of Mechanical Engineering, Dr. B.R. Ambedkar National Institute of Technology, I sincerely thank for you taking a time to share your knowledge with us. Your words have motivated us to take step towards more sustainable future. So thank you once again, Dr. Subramaniam, for your valuable time and insights. We hope to learn from you again in the future. Thank you, sir.
Thank you, Dr. Subramanian Garu, for your energetic talk and delivering this interesting topic. Actually, this is interesting and very much useful also for this current generation at this time of this global warming and controlling of this carbon dioxide. And also for your kind information, we have Jalandhar, we have many industries like sports, hand tools in both private sector as well as the central government sector. And similarly, in nearby Ludhiana, we have so many industries in textile and also many in machine tools factories. So it's I can say industrial hub this Jalandhar and Ludhiana. I think you are aware of all these industries like forging, hand tools. Such voice is mute, sir. Please unmute.
Because as I said, this is Jalandhar and Ludhiana, there is a forging industry. So it again through SIGBI, earlier the some energy efficiency project sponsored. So we executed from Hyderabad. So our people went there, taken the data, and but implementation was not in our scope. Our scope was only to identify the only energy audit part, only energy audit. Whereas recent I said about the pharma sector, even implementation also in our scope. That's why we could able to identify, implement, and show savings.
Thank you, sir. We learned many new things today, and especially important topics. Thank you, Varandar, Dr. Rajan. Thank you. And tomorrow session starts 6 p.m. and thermal power generation possible integration with renewable energy sources by Engineer Vasad Srinivas. Please join at least 5 to 10 minutes before start of the session. Thank you, sir. Good night to all.
Yeah. So we have already shared the link for this session. So please give the feedback. Okay. So thank you very much and have a good night.
Okay. Bye. Bye.
Sir, share all the PPT, sir. Slides of all.
Yeah, we will share, sir. We will share soon, sir.
I'm sending the mail because one more I have to collect Professor Srinivas Reddy. And, I will share today or tomorrow morning. I will share this mail.
Okay, sir. Okay.
Thank you.
Thank you, sir. Good night.
Oh, thank you. Bye.
Good night. Bye.
Yeah, please share the PPTs which was said that it will be.
Sure, sir. Professor
Professor,
Ramji garu,
Srinivas.
I'm sending the mail. Yes, I'm sending the mail, sir. I received few presentations.
Thank you, sir. Thank you so much.
Sure. I'll share. Thank you.
Thank you so much.
Okay, thanks.
Before proceeding.